So we got here another question, and as we said, this is a transfer function in S domain. Okay, and this is we need to apply the unit ramp. Okay, that will be our input, and also we need to find IT equal to 6.8 seconds. Then we need to find the output V out. Okay, the value at the output. Okay, so in this series we have a unit ramp, and then we got our transfer function, and we know our transfer function equal to V out, the output, okay, over the input. Okay, and we know we need to find V out, so that's what we've been asked. What is V out? Determine the output. Okay, and our V in, we know our V in, it's a unit ramp that we need to find. What is a unit ramp? So it's gonna be, we need to find a unit ramp. It's gonna be our input. What is a unit ramp? And you still remember this table? So we're going to go, and this is the formula for ramp. Okay, so this is where you have t, and this is where you got your amplitude. Okay, so this is when you work with ramp function. Okay, and times domain, and since v in S domain that we have to work with, so this is what we're gonna have. So we know this is when you have a ramp function is a over s square. Okay, now here come the other question: what is a unit ramp function? Okay, the meaning of unit that we've been asking to work with, it's just saying that the value of a equal 1. That is what we call unit. So meaning you're going to have 1 over s square for unit ramp function. Okay, so meaning v in of s will be equal to 1 over s square. Okay, so in order to solve this question, and if we are asked to solve or to find out, we are asked to find v out. Okay, and since we're working with v out, I'm going to move this denominator the other side. So we're going to have v in. Let me just start here. So we're going to have v in as transfer function equal v out is, okay, and we need to solve for, we need to write the complete equation for vs, which is gonna be v in, which is 1 over s square, times the transfer function that we had. It's gonna be 4 s plus 0.25 square. Okay, this is what you're gonna get on the for v out. Okay, and this is gonna give you something like this: s square s plus 0.25 square. Okay, then from here on, if you have to continue, you're going to look into the Laplace table, and then if into the Laplace table you don't find the formula for this, you will go for number 1. It's going to be for partial fraction. after this section, you're going to apply the partial fraction. Okay, after that you take the inverse Laplace, and then after that you're gonna replace t. You're going to replace t. Okay, so here when you take the inverse Laplace, you're gonna have now v of t, but here you're still gonna have v out, but you're going just to solve for v out to break down the equation, so then you can apply the inverse Laplace. And here you're going to have v t, which is what is the value of t? T is 6.8. You're going to solve for this. So let me just move. I'm gonna see if I still have another section. We're going just to see what's going to be involved on those 3 steps that I just show you. Yeah, we're going to create maybe this chapter where I explain how you can get your partial fraction. Okay, so this is how you go about this question. Okay, when you work with unit ramp, okay, as the input. So you're going just to apply these formulas, then you should be able to get this specific steps that you see here. All right.